and your base E, it's a unique number. They came up with this algorithm thing, and as x approaches infinity, as they keep adding larger and larger x's, it almost approaches the same number, no matter how far out you go. So if you notice, this is kind of close to 3. So if I graphed your base 3, if I put base 3 in here, 3 raised to the x, and then I did a base E, your base E is right above your ln. If I did e raised to the x, and I graphed these things, they almost look the same. Look, here's your base 3, and look at your base E. See, it came almost right on top of it. It behaves just like a base 3. It has all the attributes of all our exponents. However, it's a special case because as we increase x, you'll see the other bases will slightly go off. This one approaches the same number. It has a little bit of a unique situation. And base E, they tend to use more scientifically. If you're going into like the sciences, you use a lot of base E. When we do the logs, we do the natural log, that's the ln for base E. You can use a natural log for any of your logs, but you have to use it for a base E. So I just kind of wanted you to see that they behave the same exact way. Here's your base E, same as your 3. The domain is the same. The range is the same. And the asymptote is the same. And the point that it crosses is still 0, 1. So it behaves the same way. Okay? That's just so that we kind of can see that part. A lot of times we work on something and if we don't use it, it's like, where did this come from? Why am I doing this? You can put it in your equations the same way. You can sketch them the same exact way as you use any base 3, base 2, whatever base you're doing. The base E is nice because it's a natural log. It has like special functions. So when we get into logarithms, this one has its own little special functions in it. So that's really all I wanted to say about the base E. But you put it in your calculator just as you would any other base. Today, I really want to get to your compounds. And you did this in Algebra 2 as well. Believe it or not, Algebra 1 kids are now responsible for this formula. They're doing this in Algebra 1. And I always find this is a tough one because you guys are juniors, maybe seniors, and you probably haven't invested money. If you have a savings account, you get your little statement, you see your little interest. Well, way back in the day, interest used to be like 3%, 5%. Interest is now less than 1%. So it's not that noticeable in your accounts anymore. So when we do interest problems, we'll use like 4%, 8%, 6%. We'll use a sizable amount so that you can see a difference. Unfortunately, there's no interest rates that are like that anymore. They're like minimal. If you do even have a savings account and your interest gets posted, it's probably pennies because the interest rates are so small. But you learned this formula last year. It's basically this one. And yes, you have to memorize this. This is the shortcut when this is an annual, when n is equal to 1. So if you're going to remember anything, remember this one, because when n is 1, it comes out to be that one anyway. So we're going to take a look at this guy, and we're going to lay out all the parts. And it's really not bad to work with. This is your principal. This is called your principal. Principal or principal? That's your principal. This is your initial, and right next to this, your initial investment. Say initially I invested $10. Okay? This is your rate. Your rate always comes out as a percent, and we turn it into a decimal. N is how many times it's compounded every year. Compounded a year. If you see annual, and write these down, guys, n is 1. If you see quarterly, what do you think n is? How many quarters in a year? In a dollar? 4. Monthly? How many months in a year? 12. Daily? How many days in a year? 365. Semi-annually? Sometimes they say semi-annually. What do you think N is? 2. Good. So these are what we're going to be seeing, and that's what goes in for N. And time is T. This is your time. And generally we talk about the time each year. The only other formula you have is our PERT formula. Sometimes you can compound continuously. To compound continuously, you use a special formula. That's your PERT. Principal, base E, rate, and time. That uses its own base. The compounded continuously and the compounded daily will be the closest ones. There's a little algorithm. They don't do it like every second. There's a certain algorithm when they do continuously. If you go into finance, you'll study all these things. These are all finance terms and how you calculate interest. The one thing I want to point out is this little piece in here, this 1 plus R. So say I'm going to do something for 1 year. This 1 plus R is what actually rolls your interest back in. That means you're gaining money. If it was 1 minus R, that means you're losing money. So say, for instance, I invested $100 at 10%. Let's make life easy. What's 10% of 100? 10. So at the end of 1 year, I make $10. And what do? I add it back into my 100, right? So this 1 plus will say, okay, this is my 10 plus my 10%. It rolls it back in. So now when you do this, this comes out to be 110 if I do this for 1 year. So the 1 plus your rate says, keep rolling this in for me. Otherwise, you have to calculate your interest. You have to pull over to the side there, add it to your principal, then calculate your new principal. That 1 plus keeps rolling it in. That's why this formula has a 1 plus in it. When we do decreasing or depreciation, we'll do a 1 minus. You probably never heard of like farm equipment being depreciated. Like if someone has a farm, they buy all this equipment, they get to write off their depreciation. So how do they do that? Almost the same way, but they do 1 minus this. So they're allowed to lose a certain amount each year, and they can write that part off. That's a depreciation schedule. We're not going to do the depreciation. We will do like when populations decrease, but for our basic purposes, we're going to do a lot of your interest increasing here. So let's take a look at an example. You're given $1,000 to invest. Mark everything off. This is your principal. This is your initial investment. At 8% interest, this is your rate. How do we write this as a decimal? Good. After 1 year, this is your time. What is the value? What have we accrued of the interest compounded annually, quarterly, monthly, weekly, daily, continuously? So we basically have the same information. We have $1,000. We're putting it in at 8%. Our time is a year. What's going to change here is our N. For annually, we are 1. So we're going to take your formula. Here's your pay. We're going to substitute all your information in, and N is going to be 1. So substitute in 1,000. 1 plus, we don't really need the N because it's 1. This is what's accruing over 1 times 1. And you're just going to put this in your calculator. Now money lends itself to how many decimal places? 2. So we're just going to put this in with 2 decimal places. Let's see what this comes out to be. You should make $108. Agree? You earned 8%. You should make, we're going to keep everybody 1 year. Okay? Now, we're going to do a quarterly. What's going to change if I do a quarterly? What am I going to change?
1,080.
Oh, it's 1,000. Sorry, I put 100. Thank you. 80. I put 100 in there.
No. Like it's 1,080.
Oh, 1,080. Sorry. Sorry. 1,080. If we do quarterly, what does quarterly mean? What's our N? 4. So the only thing we're going to change here is the N. We're going to take this and we're going to put a 4 in here. Everything else is going to stay the same. We invested 1,000. We're still adding. We're compounding quarterly. 4 times 1. And we should see our money grow a little bit more. And do second enter in your calculator. If you have it set up, just do second enter. So this should be slightly more than what we made because now we're compounding 4 times a year. And give me 2 decimal places. Okay? How about monthly? What should N be? 12. So all we're going to do is change this and this to 12. So do second enter, pull it down. Remember, we kept the time as 1. I wanted to keep something stable so that you could just see what else is changing. Okay, and again, you should see a little bit more growth. What's going to happen when you round here to your 2 decimal points? You're going to go to $1,083. Okay. I'm going to do weekly. How many weeks in a year? 52. Good. So now again, I'm changing my 12 to 52. Everybody okay with this? See the pattern? And now you should see a little bit more growth. So I've gained a little bit more, not a whole heck of a lot, but a little bit more. Daily, we say N is 365. And this time we're just changing your 52 to 365. We're almost there. I just want you to see the pattern here. And see which one yields you the most money. Which kind of does make sense. And 28 cents. So we're gaining a little bit more each time. Now we're going to do continuously. Continuously is PERT. It has its own formula. Did you guys call it PERT last year? Okay. PERT, principal, base E, raised to the rate, and the time is 1 year. This should give you the best return. Not a whole heck of a lot different, but at least you get the best return here. So you should see this amount. 1.29. So we can see that that was slightly higher than the daily. Not a whole heck of a lot higher, but a little bit higher. So this was our goal, to get through these. Are we good? It's no different than the interest formula.